My name is Alex Jordan, and I'm a math instructor at PCC. I'm going to be demonstrating an online homework platform called AHEADWeBWork. AHEADWeBWork stands out among the online homework platforms because it's open source. So all the software development happens through a network of volunteers. So let's take a look at it. I'm going to go to webwork.pcc.edu, and anyone could visit this at any time. This is where you'll see a list of all of our courses that are currently using AHEADWeBWork, and I'm going to go specifically to the accessibility testing course where we do our accessibility testing. Okay, well, we don't have time today for a full demonstration of all the features, but I thought I'd at least show you the library browser. Over here on the left we have all the instructor tools, and this is the library browser. This is where instructors can view, you can see here, tens of thousands of problems that have been coded over the years by instructors and other people involved with AHEADWeBWork. Unfortunately, most of these problems that you see here, the 25,000, they have not been coded to the standards that we have adopted regarding pedagogy, the coding technique of those problems, and then of course what's relevant for this audience would be accessibility. So in the past few years we've been coding our own library of problems, and it's this pre-college algebra library that I'm going to show you a little bit of. The problems in this library are categorized by subject, and, well, just to show you some of the possibilities, let's take a look at function basics. Let's look at all of them. And the browser here is going to show us a fairly long list, I don't know, something like 50 problems in that category. Instructors can go through and peruse these and look for problems that they would like to insert into an assignment. All right, well, so let's move away from that demonstration. Let's look at a specific homework set. If I go to the main page, this is what a student sees when they first log on, a list of all the assignments that have been assigned to them. And here I have one very small demonstrations problem set for this discussion. Since this is an accessibility talk, there's two features that we really need to look at, and the first is how AHEADWeBWork handles math content, and we're going to see that in this first problem, a very small example of math content up here. You probably are aware that displaying math content is problematic for web accessibility reasons. The only real good way to have it displayed so that a screen reader can verbalize it is through MathML. And this math content here, well, I'd like to show you where it comes from. I'm going to temporarily look at the source code for this problem in this new tab. And I'll scroll down to the relevant section. But here we see the instructions: find the domain of the function, and then these symbols here are telling the AHEADWeBWork to use LaTeX for whatever the internal contents are. And so what we end up seeing is, well, here's that name of that function h appearing right there. AHEADWeBWork is currently configured to render all of that math content using MathJax. And you can tell that we're using MathJax because if I hover over any of this math content, it zooms. That's a nice accessibility feature, of course. But right now, it's actually not displaying the math using MathML. To do that, I would right-click on the MathJax object and change the math rendering to MathML if I like. I'm going to go ahead and do that for a second, but it's not, my browser currently does not like that very much, and you'll see some issues shortly with the rendering of math. But anyway, now that it is used using MathML, if we did have a screen reader attached to this, it would read it fairly well. I'm going to do something a little strange here, play a video within a video, but Karen and her group have done some testing. There's Karen right there. Have done some testing and made some screen recordings. Let's see if this works.
Evaluate this. 6 squared minus 2 squared divided by 1 plus 7.
So what you just saw there was, I don't know if you heard it. I'll go back and listen to this and see if it's audible. But what happened was Chrome's built-in voice software, ChromeVox, actually had a lot of success reading math. It read 6. It used a really high-pitched voice to read the squared to indicate that it's up there. When it got down to the denominator of this expression, it was more of a deeper, baritone voice. All that communicated the math content. And later, maybe if Karen wants to talk about it, she can tell you more about what happened with the screen reading success there. All right, so that's a success story for WebWork, the ability to have all of the math content be displayed using MathML. And what that means is that as far as screen reading goes, WebWork should always remain up at the forefront of whatever current capabilities are. It doesn't use anything fancy like Flash to render the math. So that's that. The next thing I want to show you is to move on to the second problem I have in this set. It's a very basic problem, but we have a graph. And of course, with a graph like this, you want alt text. And what we wrestled with when making these problems was, how do we make alt text? It's easy to make alt text that describes what's in the picture. But you don't want to describe it too well, or you kind of just hand the student the answers. We have to delicately balance describing it and not just, zooming in on exactly what the right information is that the non-sighted user would need to extract from the picture. So what we have here, I'll turn off images and then refresh this page. So there we can see the alt text. It's a graph of a coordinate system with linear function that goes through 0, 2 and 1, 6. Now that's the critical information that's needed for a student to answer the question. Let's bring images back. So the line passed through 0, 2 and 1, 6. I don't know who's fluent in these kinds of math problems in the audience, but they need to know the coordinates of this point, and this is a nice second point. And from that, they can find the equation for this line. So we coded in nice alt text for all of the pictures in the libraries that we've created. But there is an issue here. I put this problem in the set on purpose to show you something. Let's look at the solution. One thing that we're proud of is that all of our problem sets have walkthrough solutions. This is ugly because I changed the math rendering, so let's switch back. And these walkthrough solutions can be used by students. After the due date, they can study from these in the same way that you would use a traditional solutions manual to study. But there's a problem right now with this particular image. If I go to the alt text for it, and then we'll find it again. The alt text, you can see, is identical to the alt text from above, because when we wrote this one, I guess we forgot to put in those extra details. So this is an opportunity to show you the adaptability of WebWork. If you encounter this kind of issue, we can go into the code, and there's a lot going on here, but let me scroll down to the part that matters for us right now. I'm going to go all the way down to the solution, which happens right here, is where the solution begins. And here is the image command, insert a graph, blah, 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 that is responsible for what we see on screen there. Actually, let me revert to an old version where we're looking at a temporary version of the file. So now if I scroll down there, we'll see what it actually was using. There we go. It's putting alt text in that image command. All right, well, I want that alt text to say something new, and so I went ahead and wrote up some new alt text, and I just need to paste that in an appropriate place earlier in the code. I need to make this say alt text solution, and I can view the results. Now the alt text for this problem is more detailed. It tells people basically, it says the run is 1 minus 0 is 1, the rise is 6 minus 2 is 4. If we revert to the image version, that's what is attempted to be displayed, visually with these red lines and such. So my point is, when there's something not meeting our standards with accessibility in WebWork, we have the ability to go in there and change it. And the change, at first it will only apply to all of the students in the class that we did this in, but if it's really a good thing to do, then we can implement that change for our core library, and then all of the problems forever will be fixed. Okay, I don't know if there are many math teachers in the room, so I didn't want to get too deep into pedagogical things that are good about WebWork, but I couldn't have a discussion like this without showing at least one. So I'm going to go back to the first problem from this set. And here we were being asked for the domain of this function, and what that means is basically this is what the answer should be. This expression that you would type in the appropriate way via these instructions. So, but anyway, sometimes a student just is completely confused. They don't understand the vocabulary yet, and they might enter with something that's just way off base. This number 6, for example. Well, WebWork processes student answers in a way that's fairly intelligent, and it'll understand that this is a number and this was a different kind of thing, and the feedback message to the student up here is supposed to communicate what might specifically be wrong with their answer. And now, if you compare the feedback messages here to those from the commercial products, usually the commercial products give feedback messages that try to basically carpet bomb the student with every possible thing that may or may not have gone wrong. The idea is they make a one-size-fits-all feedback message. And it may even just be a feedback message that says, you should solve this problem by doing X, then Y, then Z, and it won't address actually what their incorrect answer was doing. So that's just one of the features that I like pedagogically about WebWork. And if you go look at that poster I had up at the beginning, which I think is part of Kayla's presentation, if you see things, references to feedback tailored to student inputs, and you see robust answers, that's what we're referring to. All right, so what are we doing now at PCC with WebWork? The libraries that we have put together really are only this one, which does very basic algebra, and we have a preliminary intermediate algebra library that we're working on. We think by the end of this summer we'll have this done, and I'm also working on college algebra. The Math 111 is our numbering system for that. We have nothing at all really for trigonometry and statistics, so in the future we'd like to create libraries for those problems. Another project, if I go back to the home page, down at the very bottom, and this is something that everyone can visit if they want, at webwork.pcc.edu, and scroll all the way down. This is a skills practice site. Anyone can log in as a guest. The intention here is to just give a free opportunity for students to just practice. So if I need practice with raising powers to powers, I can just go in here, and I don't have to have an account or anything, and I can just try my answers. I might have them incorrect, and I get a nice special feedback message there. And if I have enough success with this, I might feel more confident to go in and take a placement test. So that's one of our projects. We only have it up for one course right now, but I hope to, over the next year, get all of our courses with such practice sets up. Myself and former faculty member Chris Hughes are part of the WebWork development team at the engine level, and everything that I've been showing you up to now has basically been about individual problems and accessibility, but surrounding that, all of this is the interface and the engine, and there are still some things that could be made better on that front. Karen and her team have done a lot of research and have taken notes on things to improve. And this coming August, PCC is hosting one of the WebWork code camps where the developers get together and we hope to work on issues. So the list of items to tackle that Karen has put together is going to be extremely helpful. And we hope also by the end of this code camp that we'll have a functional VPAT for WebWork. This is an idea that came out of a faculty member who had been looking at VPATs for the commercial software and, well, what about WebWork? Why doesn't WebWork have a VPAT? And so we decided, hey, it would be a great idea to give WebWork a VPAT. It would sort of help new institutions feel more comfortable using it. So with their rough draft, with Karen's team's rough draft, I think we're going to finalize that in August. So let's see, what else can I say? If you're involved with math teaching at your institution, I hope you'll consider looking into WebWork, using it, or promoting its use among your math faculty. I didn't explicitly say this, but since it is open source, of course, the software is free, which is a huge deal. The only thing that your institution needs is the web server, and the only things that your students need are a web browser. So thank you for listening, and if you'd like to send me any more questions, the PCC contingent here at this get-together has my contact information. And actually, I was going to leave it out to Heiko, who is an instructor who uses WebWork, if he'd like to field any questions from his perspective, or Karen, who knows a lot now about the accessibility of WebWork. So I'll say bye for now, and you'll probably be hearing from me soon with a LaTeX discussion.